Hello everyone, I'm Shu Lin from Peking University. Today, I'd like to present our paper, PDL Scaffolding Problem Solving in Programming Courses. Problem-solving skills are important for students to succeed in programming courses. In CSE, students can improve their PSS by coding for programming tasks. However, when the programming tasks are challenging, students could become demotivated and lose the opportunity to improve PSS in the process. According to our experience of teaching programming courses, solving constraint optimization problems are challenging. A COP usually consists of input arguments, variables, relations, and one objective function. To solve such a problem, we need to find an assignment of variables such that all relations are satisfied and the output of the objective function is optimized. For instance, 01 knapsack is a classical COP. In this problem, there are n items and a knapsack of capacity C. Each item has its own value and weight. We're supposed to find a subset of items, such that the weight sum is at most C, while the value sum is maximal. In this problem, there are four input arguments, n, c, and items values and weights. One variable, a subset of items. One relation, the total weight is at most C, and one objective function that maximizes the total value. To help students program for challenging COPs, we introduce the idea of scaffolding. Scaffolding is a metaphor to capture the nature of support and guidance in learning. Tools using scaffolding provide temporary assistance for completing tasks or developing new understandings, and are later removed as students gain confidence and ability. The scaffolding is meant to hide or suppress overly complex issues that the student is not initially ready to encounter. Based on interactions with students, we learned that there are two challenges during solving a COP: problem comprehension and solution development. Therefore, we hope to develop a scaffolding tool that decouples problem comprehension and solution development, suppresses overly complex coding issues before the students can independently program for hard COPs. In this paper, we developed a scaffolding tool, Problem Description Language PDL, and its compiler. To solve a COP using this tool, the student is supposed to write a PDL description of the given problem, then submit it to the PDL compiler. If the PDL description has no lexical or syntactic errors, the PDL compiler can successfully implement a C program and return it to the student. Otherwise, the compiler will provide any feedback for the incorrect PDL description. The PDL compiler first conducts both syntactic and semantic analysis on the PDL description to build an identifier table, then decides to the controlling variables and generates a basic enumeration-based solving algorithm. The algorithm will be optimized by branch pruning or dynamic programming strategies if possible. Finally, the compiler implements the C program according to the algorithm design and returns it back to the user. For any incorrect PDL description, our approach provides four major types of errors and warnings, including parsing errors, type errors, unbounded variable errors, and unused variable warnings. We integrated PDL into a CS course and asked all 185 students to participate in a PDL study. To conduct a controlled experiment, we instructed all students to independently work on 6 COPs. The 6 problems are solvable with different algorithms in different complexity levels. P1 and P4 are the easiest, P2 and P5 are harder, P3 and P6 are the hardest. All students are novice programmers who took a CS1 programming and algorithm course as the prerequisite. They were ranked based on their grades in CS1 and divided into 4 groups using the serpentine system. 2 groups solved 3 problems with PDL first, then solved the other 3 problems with C. The other 2 groups solved 3 problems with C first and solved the other problems with PDL. During the study, we first asked students to fill a pre-study form about their confidence level in solving COPs. Students then learn PDL by self-study and try to solve first 3 problems with PDL or C. After that, they fill the survey form about the perception of difficulty in using PDL or C and their new confidence levels. At last, students work on the other 3 problems. To automatically assess the quality of PDL description, we integrated the PDL compiler into an online judge system. After taking in a PDL description, OJ first uses the PDL compiler to identify any lexical or syntactic error in the description. If none, OJ then compiles the C code and conducts automatic testing to execute the compiled code with prescribed test cases. The test result and feedback will be provided to the user. OJ can also take a C program as input and verify its correctness. According to the table presented here, when using PDL, students were less likely to quit, and they solved more problems with less time spent. As the problem complexity increases, the gap between the 2 approaches increases as well. According to the students' perception of the difficulty in using PDL or C, both writing and debugging PDL is significantly easier than coding or debugging C. The observations help explain why PDL helps students solve more COPs. By comparing the students' confidence levels of solving COP in the mid-survey against the data in the pre-survey, we found that the experience of using PDL significantly increased students' confidence, while the confidence growth in students using C is not significant. Many existing scaffolding techniques assist students to solve tasks, including safe subsets of general-purpose programming languages such as C and C++, and visual programming languages such as Scratch. However, none of these techniques automates algorithm design or factor out coding concerns through scaffold problem solving. In this paper, we designed PDL and implemented its compiler that automatically generates an efficient solving program for a problem described in PDL. Therefore, it decouples problem comprehension and solution development and can be used as a scaffolding approach for solving COPs. We integrated PDL into a CS course and demonstrated that PDL can lower the technical barriers for students to better PSS through coding. In the future, we plan to conduct larger-scale studies to explore how PDL helps different kinds of novice developers, for example, K-12 students, and improve PDL by generating more optimization strategies. That's all. Thank you. Any questions?